Good afternoon, ladies and gentlemen. Welcome to this Hydro International webinar on the SuDS guidance on the construction of SuDS. That's SuDS document C768. We've just clicked over to midday on my clock, so we'll get started. My name is Mark Goodger. I'm a Regional Technical Manager at Hydro International. With me today and alongside me is Chris Newton, who's also one of our Regional Technical Managers. I'll be doing the presenting. I'll be talking through the PowerPoint slides that we've got. Chris is online to assist with any questions that might come up as we go through the presentation. So in terms of what we were going to talk about today, we're looking at. We'll just go back and have a little look at the history of SuDS guidance on sustainable drainage systems, or SuDS, and SuDS have been right at the forefront of producing those guidance documents since at least the turn of this century. They had design manuals for Scotland and Northern Ireland and a separate one for England and Wales, which were published in 2000, corresponding almost exactly with the enactment of the Water Framework Directive. They were then supplemented in 2001 by a best practice manual, and a technical report followed in 2004. And then the original version of the SuDS manual, which was SuDS document C667, and a companion site handbook on the construction of SuDS, which was C698, were published in 2007. The SuDS manual stated at the time that it was a rationalized compendium to all of those earlier guidance documents, so it was bringing all of those best practice guidance documents into a single rationalized compendium that would deal with everything. And then the site handbook was a companion guide that would sit alongside that and offer practical tips in terms of constructing and building those sustainable drainage systems. At Hydro International, we were delighted to be involved with both the original SuDS manual 697 and the original site handbook 698. We were involved as funders on those projects and as part of the project steering group for both of those documents. In 2015, December 2015, the new SuDS manual, which is document C753, was published, and it wasn't really so much an update of the previous SuDS manual as a complete rewrite of that document. So it basically took it apart, built it up from the ground up again. And this, what you can see on the screen, is just taken straight from SuDS bookshop page. And it's the sort of the blurb, the back cover blurb, if you like, for the SuDS manual. And it says that it's obviously providing a comprehensive guidance on planning, design, construction, and maintenance of sustainable drainage systems, or SuDS. So there's a lot of really useful information in there for people right through all of the phases of development, right from planning stage, pre-construction design, right through to construction and maintenance. But it's 964 pages long, so it can sometimes be quite a difficult document to just pick up and be able to dive straight into. It is available as a free download, so you can go to SuStrain, the sustrain.org websites, and you can download it as a free PDF, or you can buy hard copies for it. And we did some Hydro International webinars to introduce that guidance document at the start of 2016. So if you search SuDS manual webinars in any internet search engine, you'll be able to get access to the recordings of those webinars. Again, as before, Hydro were delighted to be involved as funders for the new SuDS manual, members of the project steering group. I myself sat on steering group meetings, and we provided content and images to the authorship team that were taken forward into the SuDS manual as well. So as soon as the SuDS manual was published, it was natural that the next step for SuDS was to commission an update to the site handbook, so an updated companion guide that would deal specifically with the construction of SuDS. And this is what has resulted in the new guidance document entitled Guidance on the Construction of SuDS, which was published on the 1st of November last year. And again, it's free to download from the SuDS website, or if you go to SuStrain again, go to the resources page, go to Syria guidance, and that's free to download as a PDF. And again, if you wanted a hard copy version, those hard copies are available to purchase. Follow the same link through and it'll give you the two options. Obviously, it's 290 pages, so it's a lot shorter, a lot easier to get hold of, and it's image rich, so it's designed to be photos and images and a graphical content, as opposed to lots of verbose, lots of words in that document. And again, Hydro International involved as funders. I sat as our representative on the project steering group, and again, we contributed images, case studies, knowledge and experience to the authorship team, and again, delighted to see that taken forward and included in the document. So in terms of why these new guides were needed, at the start of the project, when we started looking at formulating and scoping the construction guidance document, first thing that we did was we went out to the marketplace and we surveyed the market to see how SuDS knowledge and experience might have moved on in the past 10 years, but to also start to pick out whether there were those instances of sites where construction could perhaps have been a little bit better. And it was also to look at, you know, you've always got people leaving the industry, taking that experience with them, and new people entering the industry continuously. So it's to look at whether we needed a guidance document that would bring that guidance right up to date with current best practice, so that new people coming into the industry have got that right at their fingertips. So as part of that survey, we went out and asked people what the main challenges and the common problems were that they face when constructing SuDS. And there was a very high level of consistency in the responses that came back, and a great sense of frustration from those involved in the construction process, that they felt that there were obstacles in their way that was preventing them from delivering on the best possible solution. So the main challenges arose from three causes. They were level changes, so levels changing through the construction process or being different from what was stated on the design drawings. Cut and fill issues not fully resolved prior to construction, and then conflicts with services once the works had started on site. Other common problems that were frequently cited including inadequacies in the design drawings, so not having full levels of full details of things like the levels, things like the capacity, the amount of storage and volume that we might need, and full details for systems and equipment such as flow controls or treatment systems or storage systems not being fully specified in those design details. Another challenge was existing site information not being comprehensively recorded, or that information not being available. So perhaps survey information missing, and again the implications of that information, not being fully appreciate in the design drawings. Bit of urban creep, so a little bit of scope addition during the build phase, so additional hard surfacing being added, but the drainage requirements for that perhaps not being fully assessed. Changes to materials, and those changes perhaps with other materials not having the same functionality, and that could be through cost value engineering type approaches, or it could be through difficulties with obtaining those materials. Changes on site or poor construction arising from a lack of knowledge of the implications of those changes, and as we said before, those new people perhaps entering the industry, and those projects being undertaken by people who perhaps not had sight of that component or that type of solution before, and so perhaps don't fully understand what's crucial to get right or how to do it. So those challenges and those problems were leading to SuDS being constructed, but the SuDS constructed would have perhaps poor visual quality. They wouldn't look as good as they could do, and that obviously leads to the perception of the general public in terms of what that's trying to achieve. Poor physical construction, so again, perhaps things like levels where you might not have a system fully draining because the levels didn't quite match up as had been envisaged at the design stage. And of course, poor functionality. You know, you've got to think about these things as being drainage components. They are there to deliver on a function. They are providing us with environmental protection and flood protection. So we need to make sure that these are first and foremost functional as drainage design or as drainage features. And then the final thing that came through from the survey was the recognition that there was a perception that sustainable drainage systems, that SuDS, are not possible or not feasible on some sites, such as those ones identified on the screen. And the most commonly identified challenge in the survey was that of contaminated land, and the perception that if you've got contaminated land, then that you can't infiltrate and therefore SuDS can't be used. So again, it was to look to challenge some of those perceptions and look to demonstrate ways in which those challenging sites can be dealt with appropriately. So that was just a little bit of the sort of the background as to sort of the history of severe guidance and why we decided that now was the right time to look at updating the guide. And if we go into the guidance document in itself, it's been set up so that it mirrors the style and the format of the SuDS manual. So it's styled in a very similar way, and it's got very similar sort of sections and elements to it. And particularly when you get into section F in the construction guidance, you will see that the individual components have exactly the same headings and are ordered in exactly the same order as in the SuDS manual. So it's very easy to sort of pick up and cross-compare between the two guidance documents, because the construction guidance is designed to be a companion guide to the SuDS manual. But it is different in its approach. So it doesn't deal with design, it doesn't deal with extensively with planning issues, and it doesn't present the information in a highly technical way. So we try to avoid the use of jargon wherever we can. Now, obviously, there are some technical terms that do need to come through, and we can't avoid them completely. So where those jargon has to be used, they're explained in a jargon buster at the end of each chapter. And predominantly, this normally amounts to between sort of 3 and 6 terms in any given chapter. And there's a couple of those that are repeated across different chapters, component being the most regularly repeated, and that lists, that's basically defined in every single chapter. And the reason for having that in each chapter means that you can just kind of dip in and look at the specific chapter, so you don't necessarily have to read the whole guide from start to finish. You can just have the section that's particularly relevant to the component or to the element that you're looking at on your given site. We also looked through the survey and through the project steering group to capture the good advice that was received and presented back to the steering group and the authorship team. And so this is presented in the traffic light system that runs through the guidance document. So we've got the sort of red, amber, green. And if we start from the bottom, so we start with the green light, there's some handy hints that appear throughout the document. So these are where we can anticipate problems so that they can be avoided, or we can offer simple solutions to commonly experienced problems. You've then got your watch points, which are where we can identify those potential problems to be particularly aware of, because they do appear so frequently on a number of different sites. And then you've got your red light, which is the hold points, and this is the point where we identify those times when we need to perhaps take a little bit of a step back. So we just need to sort of pause in the construction process and make sure that we analyze and inspect what we've done up until that point before carrying on to the next step, because it's those points where we look at the critical aspects that will impact on the effectiveness of that SuDS component and the effectiveness of the drainage once that site is completed. We also look to capture that experience that came back through the survey and the project steering group and present that in case studies. So again, each chapter, particularly the individual component chapters, will have individual mini case studies that will normally focus on a specific design aspect or a specific construction aspect where issues have been experienced. And then there's a section at the end of the guidance document where there's 5 major case studies presented at the end of the document. And they explore an entire project and then perhaps focus on 1 or 2 different areas where there were challenges, but they do look at it as a more holistic case study. In both of these types of case study, it's not a case of sort of pointing at something and going, haha, look what they did wrong. It's a case of acknowledging where we've seen those challenges, and then to look at what lessons can be learned from them, how it was resolved, and how those challenges can be avoided in the future. And then the last element that's common to many of the chapters is the checklists. So at the end of each chapter, there's a checklist to help identify those critical checks. So in particular, some of those watch points to identify what we definitely need to know and where we need to have those inspection points, both before, during, and after construction. So again, that's presented at the end of each chapter so that each chapter can be viewed in its own right. And then all of the checklists are included together in the appendix for ease of downloading and printing, so that you can take all of the checklists, put those into a project file, have them on site so that we can refer back to them easily and efficiently. So the start of the document in in section A, we've got chapter 1 and chapter 2. So we've got an introduction to the document. So you've got the 4 pillars of SuDS, which are the underlying principles of sustainable drainage systems. So sustainable drainage, of course, is there, as we said, to deliver a function. It's there to manage flood risk. It's there to manage pollution risk. It's also there in SuDS style to look at where we can take those opportunities to create better places for people and better places for nature. So that's captured strongly in the SuDS manual, but of course, if we don't understand the practical elements of construction, then these principles can quite easily be undermined. And one of the things that came up time and time again in the project steering group meetings was the construction of SuDS is different and it's not difficult. So the first thing that part A looks at is a comparison between SuDS and more traditional sort of pipe and drainage, pipe networks and pipes and manhole drainage systems. So whilst we can say, yes, SuDS have been around for quite a while, we've been constructing them for 20 years or more, they're still relatively new compared to traditional pipe drainage structures that go back 100, 150 years or more. So we just highlight some of what makes things different and why we might need to just sort of think about things a little bit differently. So at Hydro International, we've got a range of products that can contribute towards the delivery of the SuDS principles. And our products normally sit in the top half of the circle to deliver on the functional aspects of SuDS, so to deliver the flood protection, deliver the environmental protection, but they can also work in combination with each other and in combination with other SuDS components to help protect and enhance those other SuDS components and to contribute towards the delivery of amenity value, so better places for people, and biodiversity value, so better places and better spaces for nature. Part B considers the information that needs to be gathered and the issues that need to be understood prior to construction. So being properly prepared means that we make sure that we're assembling and understanding the relevant information about the site that might affect the construction of SuDS, and understanding how the scheme design works as a whole and how each part of the system interacts and relates to each other. And this is particularly relevant with regards to levels across the site. The scheme design then also needs to be cross-referenced, obviously at an early stage, to the specification to make sure that the materials used will be delivering the volumes, the storage, control the flows, control pollution as designed, and obviously to make sure that they are fully available and will be available in a timely manner to deal with the construction. But we also need to look at this as part of the environment that it's going into. So we need to give consideration to the land, to vegetation, to habitats, and other factors on the site itself and on surrounding land. And these could affect the construction work directly. So this could be something like flooding or overland flows, or coming from neighbouring sites, or services, existing services across the site. Or it could be constraints such as the timing of works that can happen due to the presence of protected species across the site. It's also important to remember that to allow or cause pollution is a criminal offence. And of course, the SuDS components can play a role in this. So some SuDS components, such as particular types of proprietary treatment devices, can be quite effectively used as temporary works measures during the construction phase, and then relatively easily remediated to provide treatment as part of the permanent works. But other SuDS components might be really susceptible to damage or impairment through exposure to construction site runoff, which could lead to costly reinstatement works. And that leads quite nicely into section C, which considers the who does what and when they do it of construction planning and phasing, and why phasing is so important in terms of getting the phasing of both the site and of the SuDS and the drainage element of it correct. So in section C, there's a set of tables that will go through the traditional roles for traditional pipe drainage systems for the design team and site construction team, and then how that might compare, and that might differ slightly from the roles that those people play in a SuDS contract. And it also emphasises the need for teamwork between those various different professions. But it draws out strongly the phasing of the works as well, and it does use a case study to highlight that. So it looks at a housing site, and it demonstrates how the phasing of the housing development might not always tie in as ideally as we'd like with the phasing of the sustainable drainage system. So it looks at a site where you think the developer will want the front end of the site completed first. So they want the sales and marketing office, they'll want the show homes completed, and then they want to work progressively back through the site so that the front end of the site obviously provides the marketing benefit for the overall development. So it looks at an example where for the early phases of sites, the materials storage and site compound and parking is actually in an area where that's been identified as the ultimate area at which we want to put something like a SuDS retention pond. So then we need to make sure that we're adequately dealing with those earlier phases before we get to the point where we can develop the complete site and put those final solutions into play. So it goes into quite a lot of detail on that. The other thing that comes through in section C is the importance of getting the right materials for the job. And this is something that actually comes up again a little bit later in the document in part E, where we look at the assessment of impact of variations. So in part C, we're looking at planning, and we're looking at making sure that we're planning to have the right materials in the right place at the right time. And then in part E, we're looking a little bit more about what happens on site when we might have to change something around, might have to make a change, and how we can deal with that, because that's perhaps imposed on us by something that comes up on site or a lack of availability. So it's important to remember that when we're looking at those changes to specified products, we need to consider the full implications of those, and we need to consider how that might affect the overall performance of the sustainable drainage systems. And it's important that value engineering isn't considered just as a cost reduction exercise, but as a means to investigate whether we can deliver the same or improved outcomes, but through the use of alternative solutions that might have the same cost base if we're improving our outcomes, or a lower cost base but delivering those same outcomes. So from an equipment supplier's point of view, there's a few things in this section that I thought I'd just draw out. There's one of the watch points that looks at proprietary systems and talks about the importance of independent verification of performance claims. And that's something that we'd support at Hydro International. That's something that we think is important, that we can stand by the claims that we make, and we can get those independently approved and verified. So there's a couple of little distinctions that need to come in to this part of the guidance document, where you're looking at different levels of verification and certification. So you've got things like British, European or international standards, so where you've got a BS or an EN or a ISO number, and that will generally set out minimum performance requirements that have to be met. So this is quite often framed in the sense of a pass-fail type standard, where either something meets a particular minimum standard or it doesn't. If it meets it, obviously it's appropriate for use. If it doesn't meet it, it's not appropriate for use. An example of that could be BS EN 858 for oil separators, and in order to qualify as an oil separator, a product must meet the minimum performance standard and minimum manufacturing criteria as laid out in that standard. In association with standards, and particularly European standards, you've got CE marking. So a CE mark is a symbol that stands for European conformity, but it generally looks primarily at health and safety requirements of a product covered under a harmonized European standard. So something that falls underneath the construction products regulations would have a harmonized standard, and it would be predominantly those health and safety aspects that we'd be looking at. If something's covered under one of those harmonized standards, it's a legal requirement in Europe for that to be CE marked, legal requirement in the EU for a CE mark to be applied. But where harmonized standards do not exist, it's actually against the law to apply a CE mark. So there's a little bit of a disconnect at the moment, because some products that help towards the delivery of SuDS do have harmonized standards, and they're already in exist. So there will be things like geotextiles where a CE mark is likely to need to be applied. And then there's other products where the harmonized standards don't yet exist. They might be in progress and they might be being built, but they're not quite finalized and published yet, and therefore we can't apply a CE mark to them. So wherever those harmonized standards exist, any of the products that we would supply would all be CE marked appropriately to those. But again, as we said, the CE mark will predominantly focus on health and safety elements and doesn't necessarily always cover the performance. So where performance can come in is voluntary programs, voluntary certification programs. So these could be things like British Board of Agreement, BBA certificates, or WRC approved Water Research Council certification programs. And these are voluntary measures that the manufacturer would enter into with the certification body. And the normal process of that is that the manufacturer would take their performance claims of their product to the certification body, and the certification body will certify the product against those claims. So a common example in the realm of SuDS would be for geocellular storage systems, such as our storm block system. So there's a wide variety of geocellular systems on the market. Some of them are BBA approved, some of them aren't BBA approved, some have been approved through other voluntary programs. None of them are CE marked because no harmonized standards apply as yet. But one manufacturer might go to the BBA with a product, and they might claim that the strength of that product is only suitable for use under landscaped areas, and another manufacturer might go with a product that is suitable for use under HGV loading areas. Now, both of those products could easily achieve BBA certification as long as that product meets the claims that have been presented, but of course they're not delivering a like-for-like performance. So it's important when we're comparing different materials and different specifications that we make sure that we're comparing like with like. And our recommendations would always be to make sure that you're asking the supplier of those systems to provide copies of the certification, or to just obtain that certification directly, and directly from the certifying body. So things like BBA certificates, again, once that certificate is issued, all of that becomes public domain information. So you can go to the BBA website and download the certificate and make sure that things are being compared on a like-for-like basis. So at Hydro International, as I said, we're very proud of the performance verification program that all of our products go through. So we put everything through our products through this comprehensive program, which can include laboratory testing at our own in-house facilities or at third-party facilities such as universities. Computer modeling to verify and simulate the systems that we're using. Field trials and pilot studies to take that laboratory and modeling experience out into the field and make sure that that behaves in the same way in the real world. And then to put those systems through those third-party certification schemes where they exist. And where those certification schemes don't exist, we'll quite often work with our colleagues throughout the industry and people like Syria and some of the authors of the guidance document like HR Wallingford to help to define those test standards and put those verification programs into place. So building on all of that, our recommendation on specifications is to make sure that specifications are as detailed as possible. So an example for that would be to look at the reference codes that we use on our Hydrobake Optimum, our flow controls. And this captures all of the design information that's being put into the system when that unit is designed. So when we're looking at comparisons to see whether there were other options for that, we can build that into the consideration and make sure that we're delivering a like-for-like performance. We'd also then provide a technical summary, and that will provide full details on how that unit is performing. So it allows us to describe that flow control and describe the performance of it. And of course, we've got the independent verification from the BBA and the WRC approved certification on those, so that we've got that assurance and verification third party of our claims. So come back to the guidance document, come back to C768 itself. As we move into section D, we look at site management. So it considers a number of site issues that we need to manage to be able to deliver SuDS effectively. And it calls out 4 key areas where key problems can arise and where there's a little bit of susceptibility. So those areas are managing soils, SuDS and site access, managing site erosion due to exposed soils and managing that silt on site, and then the establishment of planting regimes once we're nearing the end of, or during the construction or nearing the end of the construction phase. From section D onwards, the guidance document goes into a sort of consistent style of presentation. So the first couple of sections are perhaps a little bit different because they deal with different aspects, but from D onwards we get a consistent style throughout the document where we have these individual sections where we call out potential challenges, and we use this sort of universal thumbs up in green for getting it right, and thumbs down in red for those things that can go wrong. And wherever possible, that will be illustrated with a pictorial example. Where we can, we'll identify that with a picture of what can go wrong. Where we haven't been able to find a decent picture of what's gone wrong, then we'll use a picture of what we're actually trying to achieve. So soils, for example, identified as an important resource, and we can protect those and utilize them to our benefit, which can help to save costs and can help to reduce waste where possible. And then we can look at things like SuDS and site access. So there are a couple of issues there with particular SuDS components, for example, permeable paving, or for example, buried geocellular structures, where permeable paving can be damaged and impaired if we're using that for site traffic. And of course, geocellular structures, if they're buried structures, there's a structural element to that. And if we're using those as site access routes that we haven't planned for, then that could lead us with an issue. So we can look at those. Obviously, best advice is to plan for that in advance and try to plan our component location and the phasing of that and our site access routes appropriately. But we can also look at if things change, then for geocellular systems, for example, if we need to change that so that we have to traverse it with construction traffic, then by all means, at Hydro International, bring those questions to us, and we'd be happy to help with advice on what can and can't be achieved on that. We move into section E, and this is looking much more about once we're on site and the factors around constructing SuDS and the issues that need to be managed to ensure this is a successful delivery. As we've already mentioned, chapter 17 in section E talks about the impact of variations on design and dealing with enforced changes or decisions to change once on site. And it also covers changes to specification. We've already talked about that in terms of the approach in section C and chapter 9 on getting the right materials, so we won't go into that element of it again. But in section E, we do get into inspection and standard and non-standard tolerances. So there's a whole section that calls out where industry standard tolerances can be used and are particularly relevant to SuDS and SuDS construction. But it's also important to note that there could be non-standard tolerances that are site-specific or component-specific, and we need to make sure that those are taken into account, and those are also associated with those critical hold points where we need to obviously just make sure that we've got that relevant information to hand, and we take the time to assess that component and make sure that we're delivering those tolerances at the right level through the various stages of construction, so that we don't get to the end of the build and find that we've got something that didn't meet the performance that we were anticipating. That section also goes into challenging sites, so it deals with those sites where there's a perception that SuDS aren't appropriate and that they can't be delivered. So those are things like groundwater issues, contaminated land, and steeply sloping or conversely very flat and shallow sites. So I thought we'd just highlight one of those in terms of expanding a little bit on some of the case studies there and looking at a previous SuDS guidance document, which was retrofitting to manage surface water, which goes into a case study in a little bit more detail in terms of dealing with steeply sloping sites. So this was a site down in the southwest of England. It was a 2.5 hectare site. It was an existing car park with compacted fields used as seasonal overflow parking in the summer. Coastal resort, so a lot of tourist traffic in the summer. And it had known surface water problems. So we had the car park at the top of the hill generating surface water flooding issues, very steep catchment, delivering that water in a very rapid fashion to the bottom of the catchment and causing flooding issues at the bottom of the catchment. So the retrofit system that was designed there was to actually slow down the progress of water and keep some of that on the surface or close to the surface for a period of time, right at the top of the catchment. So there were sort of speed humps, traffic calming measures introduced to slow down and divert that surface water. That was diverted then into gravel trenches around the car park and grass ditches alongside car park and alongside some of the roads. Below those grass ditches were storm block infiltration systems, so geocellular systems, and they were there to provide a little bit of extra capacity, a little bit of extra storage, again at the top end of the catchment, and allow us a little bit more time to infiltrate that into the ground, rather than just letting it run down to the bottom of the hill. And then those, when they were overwhelmed, they would overflow into a storm cell storage and attenuation system, so that would then just provide us with a temporary holding reservoir for that flow as well, with an outflow and a discharge controlled by a hydrobrake flow control. So it's a very integrated system. So there's a lot of different components working together, working in harmony to deliver that the whole level of protection. And it was designed for a 100-year level of protection. And of course, dealing with the grade-ins and cascading that water down the site presented some unique challenges on that site. The installation was in 2010, and the local council, who were normally responsible for responding to, as first responders for the flooding incidents, reported at the time of publication of the Syria guidance document, which was in 2012, there were 6 flooding incidents, or 6 known incidents that would previously have caused flooding prior to the installation of that system. The other chapter in section E that I'll naturally focus on is the inlets, outlets and flow controls. As we've mentioned already, SuDS, sustainable drainage systems, it's important that they're sustainable, but first and foremost they are drainage structures. Fully functioning inlets, fully functioning outlets are fundamental to the overall performance of any SuDS component or any sustainable drainage system. They're essential for flood control, they're essential for water resilience or drought control, essential for pollution control, and they can have a material impact on the amenity and biodiversity value that's delivered. At Hydro International, of course, we're well known for the provision of our hydro brake flow controls, and this was an element of the document that we were able to contribute quite a lot of information and experience to. And the authors of C768 was gratified that they took that on board and recognised that not all flow controls are created equal, and that whilst flow controls might look similar in terms of the devices themselves, they don't necessarily perform in the same way. So a little example of this that also sort of touches back on that value engineering exercise is a site that we did a few years ago up in Scotland. And it was a social housing development site, 1.9 hectare site, 219 houses. Quite a small, quite a congested site in terms of what was going on to the site, and quite a stringent runoff restriction applied by Scottish Water, who were the receiving body for the discharge from that site. And it was predominantly focused on the flood issues as opposed to the pollution issues, because it was draining into that Scottish Water drainage system. But the original design was to look at a combination of geocellular storage systems underneath the public open space and large concrete pipes underneath the adoptable road structures, and obviously the flow controls associated with both of those types of storage system to manage the discharge. We worked with the designer and the developer to redesign that system using our Hydro Brake Optimum. This was again not long after we'd launched that range of products, so it was a good project to get our teeth into. And we were able to reduce the storage volume that was required on site by 18%, but we were able to also make sure that what we had to store, we could put a greater proportion of that into the geocellular systems, which were cheaper to install. So we reduced the install cost by 30%. An alternative approach that we could have taken on that site was to provide the same level of storage volume at the same cost, but actually provide an increase in the flood resistance and flood resilience of that site. So that's just a quick sort of snapshot example of what we can do in terms of looking at flow controls and how important that can be to the overall functionality of the system. And then, of course, it's not just about making sure that we've got the appropriate flow control and that we're using that, and that if we consider variations, we consider them appropriately. But it's also making sure that the flow control is appropriately installed in the correct position, the correct orientation, at the correct level, and if we've got different storage structures and different components across the site, making sure that we're lining up the right flow control with the correct component and the correct structure. So we leveraged a lot of our experience, both directly as suppliers of flow controls, but also the feedback that we get from approving and adopting bodies, water companies, local authorities, inspectors, when they go out to site and see what can go wrong and what can happen on site as well. So there's a couple of tips in the document about, again, making sure that we get that right and being aware of what can go wrong. And we can also look to simplify that process by providing off-site constructed solutions, so flow controls pre-installed into manhole systems, which could be plastic or concrete manhole systems. So we can drop those in and make those into a little bit more of a plug-and-play components and take some of the risk away from the site construction element and bring that into a more controlled off-site construction environment. The final of the main sections of the document is the individual components. So we've got section F, which goes into those individual components and calls out the critical points, those factors of what can go wrong and those watch points or ways to get it right for those individual components. And as we said earlier, the titles of those chapters and the order in which those chapters appear within the construction guide is exactly the same and exactly mirrored in the SuDS manual. The SuDS manual will go into a lot more detail. It'll go into a lot more detail about sourcing out perhaps gradients on the banks of things like ponds or swales, and it'll go into a lot more detail about sort of setting that up in different ways. The construction guidance will be a lot more visual and a lot more practical in that. So there is a good reason to be sort of looking across the two documents and cross-comparing them. And again, each of those chapters exists in its own right as a standalone section of this guidance document, of the construction guidance document. So it's very easy to take those individual chapters and download or print out the individual ones just for the components that are relevant to the particular site we're looking at, and just have that sort of focused information on the site, in the site folder, in the site office, so that we've got that to hand for those critical points in that construction. Again, there's a recognition both in the SuDS manual and in the guidance on the construction of SuDS. The proprietary treatment systems do have their role to play in this. They can work effectively to protect some of those more vulnerable elements of the system. And as it says in the guidance document, those systems are quite often delivered as off-site constructions, as prefabricated systems, which can make installation easier, much more straightforward, much more timely, and less prone to or less susceptible to problems on site. So just to highlight that a little bit, if we look at the bioretention section, so there's a couple of typical construction challenges associated with construction of bioretention. Things like levels constructed incorrectly, and that leading to the system not infiltrating in the way that it was intended. That could be construction material flowing into the infiltration system and causing that to clog during the construction phase without that necessarily being identified at that point. And then obviously it could lead to further problems down the line because that structure is not infiltrating as the way in which it was intended. You can look at things like incorrect soil mixes, so infiltration systems and bioretention systems. The soil mix is critical. It's a critical element of the system, so it's really important that's right. And I think there's a case study in the document that talks about a sort of a well-meaning contractor who looked at the bioretention system. It was sort of built into a little bit of a basin, and he looked at it and he thought, well, that's not level with the rest of the landscaped area over there. I'll take a little bit of the soil that I've got from another part of the site, a little bit of my cut, I'll fill it in here, and there we go. We've got a nice level part of the site. That looks great, but of course he didn't realise that basin had been designed for a reason, and the soils that were put there were a specific soil mix to deliver an infiltration volume, and that obviously impaired the performance of the system. Rectifiable, of course, but it did mean going back and re-excavating some of that system and taking away some of the soils and re-importing some new soil to meet that objective. Then there's also, of course, the inadvertent sort of effect, the inadvertent effect of infiltration systems. So things like running a site plant across an infiltration system, and then that lead into an overcompaction of those soils and impairing again the infiltration capabilities of it. And again, it's purely about just not being aware that was a partially constructed SuDS component at that point in time. So perhaps just simple things like maybe just sort of fencing that off would have improved on that. And then you've got the integrations between a SuDS component and the surrounding landscape. So you could have things like mulch washing off landscaped areas onto pervious systems and impairing the infiltration of that. But similarly, if you've got a SuDS component that's designed to be mulched, you could have that mulch, if it's not protected or if the levels aren't quite right, you could have a bit of loss and erosion of that mulch onto neighbouring parts of the system, which might then impair the environmental protection that system is designed to deliver. So One of the potential ways around that would be to look at one of those prefabricated type systems. So in terms of bioretention or biofiltration, we've got our hydro biofilter, which is a proprietary component delivered to site with the right soil materials, pre-installed, pre-filled to the correct levels, and that's protected against the ingress of construction traffic during the construction phase, and then towards the end of the construction phase and the end of the build, we'll come along and we'll assist to make sure that the functionality of that system hasn't been affected or impaired in any way. So we'll do a couple of simple tests, but we'll also open that up so that it starts to accept the flows from the fully developed site. I'll come back to this in a little bit, but Chris, who sat alongside me, will be doing a webinar in the not too distant future that will deal a little bit more specifically with the biofilter system and how that can fit into street design and into SuDS design. So just a quick summary in terms of the construction of SuDS guidance, document C768. As I said, it's free to download from the Civia and SuStrain websites. Type in construction of SuDS, that'll take you to it. There's a link in some of the emails that you've been receiving as well that will take you directly to it. It's free to download, but if you do want a hard copy, and I know some people like working off hard copies, there is a hard copy available to purchase as well. And that guidance document that guidance document informs design. So whilst it's focused on construction, some of those important watch points and handy hints can be brought right forward into the design phase. It helps to inspire team working and improve communications between the different stakeholders and the different people involved in delivering good SuDS, both at the design stage, planning stage, and construction stage. Helps to identify potential problems before they become problems so that we can avoid them or we can overcome them. Helps to deliver those better outcomes and deliver on sustainable water management, and take that all the way back to what we're trying to achieve, which is to deliver sustainable drainage systems that are nice to look at. They're providing good amenity space, nice to be around. They're providing some environmental value and biodiversity value, but fundamentally they're protecting people. They're protecting homes in terms of protection against flooding, and they're protecting the environment in terms of making sure that we're managing the pollution from our built environment in a sustainable and responsible way as we possibly can. There's a couple of little things that I just wanted to flag up just before we finish. I think we're running close to time, so we won't really be able to go into any of the questions, unfortunately, but I can see Chris has been responding to those, so we'll feedback the outcomes of those. There's a new project that Civia have just started on delivering integrated water management through the planning system. It's a little bit more all-encompassing, so it doesn't just look at SuDS, it doesn't just look at drainage side, it looks at water resilience as well. That project started at the end of last year, and similar to this, the construction guidance project, the first thing that we're doing with that is looking to gain knowledge and experience and information from the industry. You guys are at the front end of this, so your knowledge and experience, your thoughts are of immense value to us to scope out and define the direction of that document. Associated with that, there is of course a chance to win a £50 Amazon voucher just in time for the end of the January sales, because the survey's open until the end of this month. So search integrated water management survey, go to SuStrain website, go to the news page, you'll find that link to that survey. I'd encourage as many people to fill that in as possibly can. And the Welsh Assembly Government are currently running a consultation on sustainable drainage for new developments. Again, search Welsh Government SuDS or go to the consultations.gov.wales site, view the open consultations. And if you work in Wales and have experience in Wales, not directly involved with the government there, but I'm sure they'd be appreciative of as many responses as they can get. that survey's open until, or that consultation's open until the middle of February. You will get a survey that is much more specific to this webinar that will launch on your systems when we leave in a couple of minutes. It will also come through in an email that you'll get probably in about an hour's time. That's just a chance for you to reflect on me and how I presented this information today. Again, fully appreciative of your comments associated in that, so that it can help us to define our webinar program going forwards and how we can improve those and make them as useful for you as the audience as possible. And then there's a couple of upcoming events. So those of you in the southeast, there is a SuStrain conference coming up. It's an afternoon conference. It's in London at the SuStrain offices just by the Barbican. Free to attend, limited places, so go early. Go to the SuStrain website, go to the events page. You'll be able to log in there. As I said, obviously this webinar has been recorded. We'll be releasing the recording to that. Obviously, if any of your colleagues weren't able to attend and they want the chance to participate in a live session, we're not planning any on this topic ourselves at Hydro, but Syria and SuStrain are looking at a webinar themselves on the 26th of February. And actually, I used some PowerPoint slides that Syria provided in the building of this presentation, so there'll be a lot of similar sort of information will come through on that. Again, obviously free to attend. Go to the SuStrain website and sign yourself up under the events page. And as I mentioned earlier, Chris will be delivering a webinar in the not too distant future that will focus a little bit more on the biofilter that I flashed up at the end. Date hasn't quite been fixed on that, so we'll look at the calendars and we'll look at the events that are coming through. Make sure that we identify a free date, and that information will be coming out to you shortly, in the same way that the information on this has come out, so we get mail shots out to people. That's brought me right bang up to 1 o'clock. So I'll conclude the presentation at this point.